Hello guys, you're back with our next lecture. In this lecture, let us go through the two basic operations on stack, guys. So the first operation is push and the second operation is pop. So basically what is a push, guys? Push is nothing but pushing an element into the stack, right? Yes. Okay, so let us start the discussion, guys. So before starting the discussion, I just want to give you an example. So with the help of that example, we can write the code and we can understand the concept really easily, guys. So let me take the previous stack only. Okay. So in the last lecture we used this stack, right? Yes. So let me take those pieces of paper which we have used. Okay. So assume that the green or black came first. Okay. So in video it is black, but for me it is green. Okay. Yes. So it came first. So the first thing, before entering it into the stack, you will check whether the stack is full or not. So basically if it is full, so assume that the stack size is 2 only, okay, and if a new element wants to enter, so the thing will say that it is full, right? Yes. So that is the reason why before inserting an element, we should always check whether the stack is full or not. So if it is not full, you can enter the element, okay. And remember one more thing, the initial value of a top will be -1, guys, okay. So once you enter the first element, you will make its top +1 and you will push the element, okay. And if one more element comes, again you will check the condition whether the stack is full or not. No, push it, okay. Increment top, and now top will point to this 1 and store it, okay. And if one more element wants to come, again check the condition. So again we are having 2 slot also, so this element will also be pushed, okay. The top will be incremented, then the element will be pushed. Got it? Yes. So now when one more element comes, I think both of them are black, okay, sorry for that. So assume that the next element comes, so it will check whether the stack is full. Yes, the stack is full, hence the insertion will not be done. So in this way you need to write the logic of insertion, guys. Got it? You got the idea, right? So how the push operation will be done. Okay, so again we'll be back with these type of example for pop also. So now let us go through the algorithm and the understanding. Okay, so the process of adding a new element to the top of stack, so remember always from top only you will add the element, is called push operation. So after every new element is inserted at the top, after every push operation, the top is incremented by 1. Okay, so when stack is full, no new element should be added. Okay, so now let us understand the logic, guys. So we will be having a push function. So it will take the input yes. So yes is nothing but our stack. Okay, and n is nothing but the number of elements which could be stored in the stack. And top is nothing but the topmost index. So basically at what index it is there. And x is nothing but the element which you want to insert. So these are the 4 parameters which we are pushing with the push. Okay, so once once you ask to push a particular element, so you will check if top double is equals to n-1. So what exactly it means? So when top will be n-1, guys, so basically here the size is a 3, guys, so you can push 3 elements. So what is n-1? That is a 2. So when the top will be 2, guys, when we are having 3 elements, right? So indirectly at that time the stack is full. So at that situation you can say that the top is equals to n-1. So that is what we are printing, guys. So print stack is overflow. So basically we are checking whether it is full or not. So if it is not full, just increment the top, substitute the value x into our stack, that's it. And again you can call the push, again it will check for condition, increment push, remember the order, okay? Yes. And the default value of a top will be -1, guys. Got it? Yes. Okay, so in some examinations they might ask the time complexity of a push. So the worst or the best case of time complexity for push is a big O of 1, guys. So few of you might be asking that how did I say it is constant time or big O of 1? So basically, is there any loop in it inside this function, guys, like for loop or while loop or any kind of loop or iteration statement or recursion? No, right? Yes, so that is the reason why it can complete it in a constant time. So that is a big O of 1. Got it? Yes. Okay. So let us now move to pop operation. Okay. So before going to pop operation, So what you should check, guys, so you should check whether the stack is empty or not. So if it is completely empty, so from this stack what you can pop, guys, so there is no element to pop, right? Yes, so that is the reason why before popping you should check whether the stack is empty or not. Okay, yes, so assume that there are 3 elements inside it. Okay, so the stack is full at this moment of time. Okay, so what you can pop, guys, so you will be popping the topmost element. So you need to store this topmost element in some element, and you should just decrement this top, right? Yes. Okay, so again, if one more pop operation is done, substitute this value in some variable, decrement this top. Done. So at the end, so if you are decrementing the last element, what you will decrement, guys, so it will go to -1. So once it reaches -1, it will say that the stack is empty. Got it? Yes. So now let us continue. Okay, so the process of deleting an element from the top of the stack is called as pop operation. So after every pop operation, the top is decremented by 1. So that is the reason why from 5, 4, 3, 2, 1 to -1 it will go. Got it? Yes. So if there is no element in the stack and the operation is requested, then this will result in stack underflow. So underflow is nothing but empty. Overflow is nothing but full, guys. Okay? Yes. So pop s comma top comma n. So s is nothing but our stack. Okay, top is nothing but our topmost elements index, and n is nothing but the total number. So basically in this example, so this s is nothing but an array, guys. So we are using an array representation or array implementation. Okay, yes. So if top double is equals to -1, so basically when will top point to -1, guys? So it will point when the stack is empty. So if it is true, you will be printing the stack is empty. Else you will first substitute the value, guys. So you will substitute whatever value is there, you will substitute it into a variable, then you will decrement it by 1, guys. Okay, and you will return the value x. So basically if you want to print the deleted element is b, deleted element is c. So if you want to print in that way, you can print it. Got it? Yes. So these are the 2 most important and popular operations of stack, guys. So the one more thing is pop operation takes a big O of 1. So again here there are any loops? No. Hence it can be done in a constant amount of time. That is big O of 1. Got it? Yes. So you might be saying that, okay, so we got the idea about a stack, push and pop. So can we expect a question from these kind of concepts? Yes, the answer is yes, guys. So in 1991 GATE, they asked the push and pop operations only. And one more thing is, in 2021 in my set, in set 1, they gave push and pop operation with NQ and DQ. So basically they combined a stack and queue operations, guys. So basically by that they gave a question. Okay, so in that way you could, that is also a simple question in which the first stack operations are nothing but push and pop, guys. Okay, so these kind of questions could also be asked, so don't neglect these questions, guys. Okay, these are really easy also. Okay, yes. So let us try solving it. Okay, so the first step they told is a push 20. So I'll be just solving it in this gap, or okay, so let me fold it. What's there? Right, just give me a second. Okay, so what is the first thing they did? So push 10. So let us assume a stack. Okay, so here they did not give any size or the indexes and all those things, so they just gave the sequence. So find a popping sequence, they asked, that's it. Okay, so they told to push 10. Okay, so after that they told to push 20. After that they told to pop. So if we pop, what element will come out, guys? So 20 will come out. So whatever is on the top will come out. So after that again they asked us to push 10. Okay, so after that they asked to push 20. Okay, so after that they done 3 times pop. So they popped 20 and they again did pop, so they got 10. So again they did pop, they got 10. So always make sure that you are writing in the exact order, guys, because if you write in reverse order, the options will always be confusing. Okay, similarly the last push is a 20. So again we pushed 20 and we are going to pop it. So 20. So this is your series. So 20, 20, 10 and 20. Okay, this is an MSQ, you can say, guys. Okay, sorry, MCQ. Okay, yes. So this is your answer. So in this way a question has been asked, guys. Okay, yes. So that is the reason why each and every topic is really easy and important also. Okay, yes. So I hope everyone got some basic idea on a stack and the push and pop operations. So in the next lecture, let us go to the application of stack, and we'll be discussing about evaluation of arithmetic expressions. So basically how these arithmetic expressions are solved or evaluated using stack. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.